What if everything you think you know about the universe is nothing more than an illusion? Picture this: the vast, infinite expanse of space, dotted with galaxies, black holes, and mysteries beyond our wildest comprehension. But what if the truth lurking beneath the surface is far stranger, far more unsettling than we've ever dared to imagine? The universe isn't just a cold, empty void. It might be watching, it might be alive, and it might not even be real at all. Today, we're diving deep into 25 of the most chilling theories about the cosmos, ideas that will make you question the very fabric of reality. From sentient black holes that hunger for consciousness to the spine-tingling possibility that we're all living inside an advanced simulation, these aren't just science fiction. They're real hypotheses debated by physicists, astronomers, and philosophers, theories that challenge everything we thought we knew. Could the universe be a hologram? Are there hidden dimensions where other versions of us exist? And what if the eerie silence of space isn't silence at all, but something far more sinister? The deeper we look, the more the cosmos seems to whisper secrets we're not entirely prepared to hear. This journey isn't for the faint of heart. We'll unravel mysteries that blur the line between science and nightmare, exploring concepts so bizarre they'll linger in your mind long after this video ends. And here's the most unsettling part: some of these theories suggest we're not alone, but not in the way you'd expect. Forget little green men. The truth could be something far more incomprehensible. So take a deep breath, steel your nerves, and prepare to venture into the unknown. Because once you hear these theories, the universe will never look the same again. What if your entire reality, every memory, every person you've ever known, even the universe itself, was nothing more than a fleeting hallucination conjured up by a lone, disembodied brain floating in the void? This isn't science fiction. It's the Boltzmann Brain Paradox, one of the most unsettling ideas in modern physics. The theory starts with a simple but bizarre fact about quantum mechanics. In an infinite universe, random fluctuations can create anything given enough time. And I mean anything, even a fully conscious brain, complete with fabricated memories of a past that never actually happened. According to this paradox, the odds of such a brain spontaneously forming in the emptiness of space might be higher than the odds of the entire universe evolving naturally over billions of years. Think about what that means. Right now, you could be that brain, a single, isolated consciousness tricked into believing you're living in a vast, intricate cosmos. Every sensation, every experience, every law of physics you think you understand might just be an elaborate illusion. The stars, the planets, even time itself could all be figments of your own deranged imagination. Scientists call this the ultimate solipsistic nightmare. If Boltzmann brains exist, then statistically, there are far more of them drifting in the void than there are real, biological minds like ours. So ask yourself, how do you know you're not one of them? The unnerving truth is you can't, and here's where it gets even stranger. The cosmic web, the vast, interconnected structure of galaxies, looks eerily similar to the neural networks inside a human brain. Some researchers argue this isn't just a coincidence. What if the universe is a brain? Or worse, what if you're the glitch inside one? The Boltzmann Brain Paradox doesn't just challenge what's real, it threatens the very foundation of science itself. If conscious minds can randomly pop into existence, how can we trust any observation or experiment? Every discovery, every law of physics, even the certainty that the past existed at all, could be nothing more than a fleeting hallucination. Some physicists, like Sean Carroll, argue this theory is absurd not because it's impossible, but because it renders all knowledge meaningless. After all, if reality is just a dice roll in an infinite void, why bother searching for truth at all? Yet here's the terrifying catch: no one can fully disprove it. The math works. In a universe that lasts long enough, randomness could assemble a fully formed mind out of nothing. Imagine an AI-generated face flickering between versions, never settling. Each iteration, a new unstable consciousness briefly convinced it's real. That's the nightmare of Boltzmann brains. They wouldn't just be glitches, they'd outnumber us by an unimaginable margin, making it statistically more likely you're one of them than a person anchored in a stable universe. Carroll and others counter with a common-sense argument. If science leads us to a conclusion this absurd, maybe we've taken a wrong turn. They propose that unknown laws of quantum mechanics or cosmology might prevent these rogue consciousnesses from forming. But until we find those laws, the paradox lingers like a shadow over every experiment ever conducted. It whispers that the cosmos might not just be stranger than we imagine, but stranger than we can imagine. And that raises an even darker question. If a Boltzmann brain can't tell it's an accident, how do we know our scientific laws aren't just temporary quirks of a dying universe? What if gravity, light, even time itself are just fleeting patterns in the chaos, and one day they'll dissolve like smoke, taking all of reality with them? There's something far more terrifying than being torn apart by a black hole being preserved against your will. Imagine floating toward the inky darkness of an event horizon, the point of no return where gravity stretches your body into a molecular noodle. But here's the twist. According to the black hole information paradox, you might not just die there. You could be transformed into a holographic imprint, your entire existence encoded onto the surface of the black hole like cosmic graffiti. This nightmare starts with a fundamental law of physics. Information can't be destroyed. Every atom, every memory, every flicker of consciousness you've ever had is data the universe refuses to erase. But black holes defy this rule. Once something crosses the event horizon, it should vanish from reality forever, taking its information with it. That's the paradox. If black holes delete information, the entire framework of quantum mechanics crumbles. So physicists like Stephen Hawking proposed a horrifying solution. Your essence, your thoughts, your memories, even the way your atoms were arranged gets scrambled and smeared across the black hole's event horizon like a scrambled DVD. You're not gone, you're pixelated, stretched into a two-dimensional shadow of yourself, while the original you gets shredded into atomic confetti. But it gets worse. Some theories suggest this process isn't just messy, it's infinite. As you fall, time distorts so severely that from an outsider's perspective, you never actually cross the horizon. Instead, you're frozen there, duplicated over and over by the extreme forces at play. Every atom of your body gets photocopied onto the surface, meaning countless versions of you could exist simultaneously, some spaghettified beyond recognition, others trapped in an endless loop of near death. This isn't just about physics, it's about identity. If a perfect copy of your consciousness lingers on the event horizon, is that you, or are you the screaming, stretched version plunging into oblivion? The paradox forces us to confront a chilling question. What does it even mean to exist when the universe can duplicate, distort, and archive you against your will? And then there's the holographic principle. Some scientists argue the entire universe might operate like a black hole's event horizon, with every event, every particle, even our perception of three-dimensional space being nothing more than a projection from a hidden, two-dimensional surface. If that's true, the horror of being holographically encoded isn't just a black hole quirk, it's a universal condition. You might already be a shadow on some distant cosmic wall, unaware you're just data in a larger, unfathomable system. What's truly unsettling is that we know black holes exist. We've photographed them, which means somewhere out there, this paradox isn't just theory, it's happening. Right now, something or someone could be trapped in that limbo, and if the universe has its way, one day, so might we. What if the very fabric of reality is resting on a knife's edge, a fragile, temporary state that could collapse without warning, rewriting the laws of physics in an instant? This is the horrifying premise of the false vacuum hypothesis. a theory suggesting our universe might be nothing more than a cosmic house of cards, one quantum fluctuation away from total annihilation. It starts with the idea that what we call empty space isn't empty at all. Quantum fields permeate every inch of the universe, giving rise to particles, forces, and the constants that govern reality. But what if these fields aren't in their true, stable state? Imagine a ball sitting on the slope of a hill. It looks steady, but the slightest nudge could send it tumbling into the valley below. That's our universe right now, perched in a metastable false vacuum, a precarious equilibrium that could shatter at any moment. If this decay were triggered by a random quantum event, a high-energy experiment, or even just bad cosmic luck, a bubble of true vacuum would form somewhere in space. Inside this bubble, the fundamental laws of physics would be utterly different. Gravity might vanish, light could cease to exist, matter itself might unravel into unrecognizable forms. And the worst part, this bubble would expand at the speed of light, erasing everything in its path. One moment you're sipping coffee on Earth, the next an invisible wave of annihilation sweeps through the solar system, rewriting reality before you even have time to scream. Stephen Hawking himself warned about this existential gamble, noting that the universe's apparent stability might be an illusion. The math is chillingly clear. If the false vacuum decays, there's no warning, no escape, and no way to survive. Entire galaxies would blink out of existence, their stars and planets transformed into something unknowable. The scariest part, we wouldn't see it coming. The collapse moves at light speed, meaning the destruction reaches you at the exact same moment you detect it. But here's where it gets even stranger. Some physicists argue this might have already happened countless times. If a true vacuum bubble can form, it's possible our universe is just one of many temporary pockets in a greater cosmic landscape, each with its own random set of physical laws. We might be living in a lucky bubble where conditions allowed life to form, while outside an infinite sea of unstable vacuum lurks, waiting to reset the board. The false vacuum hypothesis isn't just a thought experiment. It's a reminder that reality as we know it could be far more fragile than we ever imagined. And the most unsettling question of all. If the universe is this unstable, why hasn't it collapsed already? Is it because the odds are in our favor, or are we just living on borrowed time? What if death isn't the end, but an illusion your consciousness refuses to acknowledge? Quantum immortality is a mind-bending theory that suggests you can never truly experience your own death, no matter how grim the odds. This isn't magic or wishful thinking. It's a terrifying consequence of the many worlds interpretation of quantum mechanics, where every possible outcome splits reality into infinite parallel universes. Picture this: a man sits at a table with a loaded revolver playing Russian roulette. In most timelines, the trigger pulls and his story ends, but in at least one universe, the chamber clicks empty and he walks away unharmed. Quantum immortality proposes that your consciousness only persists in the timelines where you survive. From your perspective, you'd always be the lucky one, no matter how statistically improbable your escape. There are eerie accounts from people who swear they should have died car crashes, falls from great heights, even failed suicide attempts, only to describe a sudden, unexplainable shift in reality, as if they'd somehow slipped into a world where the impossible happened. Now take Schrödinger's famous cat trapped in a box with a 50-50 chance of being poisoned. According to quantum mechanics, the cat is both alive and dead until someone opens the box. But here's the horror twist. If the many worlds interpretation is real, there's no single outcome. The universe splits. In one world, the cat meows. In another, it lies lifeless. And if the cat were conscious, its experience would only continue in the realities where it survived. The other branches, they'd exist, but the cat's awareness would vanish like a snuffed-out flame. This raises a disturbing question. If consciousness always follows the path of survival, could we all be unwitting immortals, hopping timelines without realizing it? Imagine a version of you died years ago in a tragic accident, but you didn't experience it because your awareness jumped to the nearest reality where you lived. Some theorists argue this could explain the eerie sensation of déjà vu or the Mandela effect, where large groups remember events that never happened. Are these glitches in the matrix or evidence of timeline shifts? But quantum immortality isn't a free pass to invincibility. It comes with a chilling caveat. While you might never witness your own death, everyone around you would. In the branching universes where you perish, your loved ones mourn. In the ones where you survive, they might notice odd inconsistencies, details that don't line up, memories that conflict. Worse, over time, the cumulative effect of near-death escapes could leave you stranded in an increasingly improbable reality, where world events, technology, even the people you know seem off. The theory takes on a darker edge when you consider aging. If consciousness always finds a way to persist, does that mean you'd live forever even as your body fails? Imagine reaching 120 years old, 200, 500 trapped in a crumbling body, outliving everyone you've ever known because quantum mechanics won't let you die. Some interpretations suggest that at a certain point, the odds of survival become so infinitesimal that your consciousness might be forced into artificial realities, simulations, or uploaded minds, just to keep the thread of awareness from snapping. Critics argue this is a philosophical nightmare, not science. After all, if we can't observe these alternate timelines, how can we prove they exist? But supporters counter that the math behind quantum mechanics demands these branches exist. We're just blind to them. And that's the real horror of quantum immortality. It doesn't offer comfort. It traps you in a cosmic game of chance where death is always real for everyone else but never for you. The universe isn't just silent, it might be hiding. Imagine an infinite, pitch-black forest where every civilization crouches in the shadows, terrified to make a sound. This is the dark forest hypothesis, one of the most chilling explanations for why we've never heard from extraterrestrial life. It's not that aliens don't exist. It's that every intelligent species knows the same grim truth. Broadcasting your location is suicide. Think of Earth in the 19th century, when explorers hacked through jungles, unaware of the predators watching from the trees. Now picture that on a cosmic scale. Advanced civilizations could be everywhere, but they've learned the hard way that contact is fatal. The moment a species reveals itself, by sending radio signals, launching probes, or even just growing too fast, it becomes a target. Because in a universe where resources are finite, the most logical strategy for survival isn't friendship, it's preemptive strike. This isn't paranoia. It's game theory. Any civilization advanced enough to detect others would face a brutal calculation. If they're peaceful, revealing themselves risks annihilation by someone less scrupulous. If they're hostile, staying silent lets them ambush rivals. The safest move, total radio silence, no signals, no megastructures, no evidence they ever existed. The universe isn't empty, it's full of civilizations pretending to be ghosts. That's why SETI's search for alien signals might be dangerously naive. Every time we beam messages into space, we're essentially shouting, "Here we are." Into a forest where something hungry is listening. Chinese science fiction writer Liu Cixin popularized this idea, but the math behind it is coldly rational. If even one predatory civilization exists, the only survivors would be those who never spoke up. And the scariest part, this could explain the Fermi paradox, the glaring contradiction between the high probability of alien life and the utter lack of evidence. The silence isn't a mystery, it's a warning. Those who survive know better than to answer. But what if we're already too late? Some theories suggest Earth's technological adolescence has already made us visible. Our radio waves have been leaking into space for over a century, creating a growing bubble of detectable noise. If the dark forest is real, something might already be tracing those signals back to their source. Yet there's a sliver of hope. Maybe some civilizations have found ways to communicate secretly through quantum entanglement or other undetectable means. Or perhaps predators are rare and most aliens are just as terrified as we'd be. But until we know for sure, the dark forest hypothesis leaves us with a harrowing choice. Keep shouting into the void or join the silence before something answers. What if the ticking clock on your wall is nothing but a cruel trick of perception? Physicist Julian Barber made a radical proposal: time doesn't flow. It doesn't pass, it doesn't even exist. Instead, the universe is a vast, frozen landscape of infinite nows, stacked like frames in a film reel that never plays. Every moment, your birth, your death, the heat-death of the cosmos exists simultaneously, locked in place. The sensation of time moving, that's just your brain stitching these static instants together, like flipping through a flipbook and mistaking the illusion for motion. Picture Salvador Dali's melting clocks dripping off tree branches. That surreal image captures the nightmare of Barber's theory. If time is an illusion, then the past isn't gone and the future isn't coming. Your childhood self is still out there, frozen in a moment you can never return to. The version of you reading this in 10 years, already there, suspended in the cosmic slideshow. Even your memories aren't records of what was there, just another static frame in the endless collage. This isn't just philosophy. The math behind quantum gravity suggests time might vanish at the most fundamental level. At the scale of atoms, particles don't experience time the way we do. Events unfold without a clear before or after, like a shuffled deck of cards where every possible arrangement exists at once. Barber calls these frozen moments nows, and in his view, reality is a mountain of them, stretching infinitely in every direction. So why do we feel time passing? Think of a movie projector. Each frame is static, but the light flickers so fast your brain merges them into motion. Barber argues consciousness works the same way. Your mind hops from one now to the next, creating the illusion of continuity. But here's the twist: there's no actual movement between them, no thread connecting cause and effect. Just separate, isolated slices of existence where you're born, live, and die, all at once. This shatters everything we take for granted. Free will. If every decision is just another frozen moment, choice might be an elaborate hallucination. Death merely one frame in the stack, no more final than the others. Even history becomes a misleading story we tell ourselves to make sense of the chaos. The Big Bang and the end of the universe sit side by side in this cosmic gallery, separated only by our desperate need to arrange them in order. Critics argue this reduces life to a meaningless slideshow. But Barber offers a haunting counter. If every moment exists forever, then nothing is ever truly lost. Your happiest memories aren't fading, they're still out there, perfectly preserved. The catch: you can't revisit them. You're stuck in your current now, like a prisoner in a cell with infinite, unreachable windows, and that raises the darkest question of all. If time isn't real, what does that make us? Are we just fleeting patterns in the static, convinced we're moving towards something when in reality, we've already arrived everywhere, everyone, all at once? The universe might be less like a river and more like a museum where every exhibit is labeled now, and the exit sign, that's just another illusion. What if every solid object you've ever touched, every mountain, every star, even your own hands, was nothing more than a ghostly projection, an illusion cast from the edges of the cosmos? Welcome to the holographic principle, a theory so bizarre it suggests our three-dimensional universe might actually be a two-dimensional shadow show, playing out on the surface of an unfathomably distant boundary. The idea begins with an unsettling property of black holes, where information about objects that fall in gets encoded onto the event horizon like microscopic etchings. But in the 1990s, physicists Gerard T. Hooft and Leonard Susskind took this concept further. If black holes can store three-dimensional reality on a two-dimensional surface, why not the entire universe? They proposed that everything we perceive, every galaxy, every law of physics, even time itself, might be a holographic projection from the cosmic horizon, the outer limit of the observable universe. Think of it like a movie theater. The screen is flat, but the images appear to have depth. Now imagine that screen is the edge of existence, and we are the flickering illusions. The atoms in your body, the light from distant stars, none of it would truly exist in 3 dimensions. Instead, it's all data, meticulously rendered by some unfathomable cosmic projector. And the creepiest part, there might be evidence. In 2014, scientists studying gravitational waves discovered something eerie. Space itself seems to have a pixelated limit, a smallest possible unit of resolution, like the dots on an old television screen. At extremely tiny scales, reality appears to glitch, as if we're hitting the edges of the universe's rendering power. It's as though the cosmos has a finite amount of storage, and when we peer too closely, we see the static lurking beneath the illusion. Picture the digital world of Tron, where glowing grids define reality until a virus corrupts the code, exposing the fragile framework underneath. That's what some physicists believe could happen if the holographic principle is real. Under extreme conditions, near a black hole, or at the birth of the universe, the projection might falter, revealing the 2-dimensional scaffolding beneath our feet. But here's the real existential kicker. If we're living in a hologram, who or what is holding the projector? Are we the simulation of some higher dimensional beings, or is the universe simply encoding itself in the most efficient way possible? Even stranger, if all information is stored at the boundary, does that mean our real selves exist out there, frozen on some cosmic hard drive, while the versions we experience are just fleeting echoes? The holographic principle doesn't just rewrite physics, it rewrites meaning. Free will, identity, even the passage of time could just be side effects of a deeper, hidden code. And if that's true, then every thought you've ever had, every emotion you've ever felt, might be nothing more than a ripple on the surface of a vast, unknowable ocean. So the next time you reach out to touch something solid, ask yourself, are you really feeling an object, or just the universe's best approximation of one? The answer might be staring back at you from the edge of reality itself. What if the reason we can't find the edge of the universe is because there is no edge, just lines of code in a supercomputer the size of a galaxy? This is the simulation argument, a theory so compelling that even Elon Musk has said the odds we're living in base reality are 1 in billions. Philosopher Nick Bostrom didn't just suggest we might be in a simulation. He laid out a chilling trilemma, 3 possibilities, one of which must be true, and 2 of them are terrifying. First, almost every civilization goes extinct before reaching the technological capability to create simulated realities. Second, if they do reach that level, they choose not to run ancestor simulations, perhaps out of ethics or disinterest. And third, they create so many simulations that the number of artificial minds dwarfs organic ones, making it statistically inevitable that we are among the simulated. Bostrom's math is brutal. Unless you believe every advanced civilization self-destructs or loses interest in its own history, the third option is almost certain. But here's where it gets eerie. Quantum mechanics behaves strangely like a simulation struggling to render reality efficiently. At the smallest scales, particles don't have defined properties until observed, as if the universe is optimizing processing power by only loading details when needed. Even the speed of light could be a built-in limit, preventing the system from being overloaded by too much information at once. Think of a video game where distant landscapes are blurry until you approach them, saving memory. Now imagine that's not a design choice, it's the universe's way of staying operational. Then there are the glitches. In 2005, scientists analyzing cosmic microwave background radiation, the afterglow of the Big Bang, found bizarre, cold spots in the sky where the physics just doesn't fit. One theory, these are artifacts in the simulation, like corrupted pixels in an old DVD. Some researchers have even proposed that high-energy cosmic rays, which inexplicably break known physical laws, might be error messages, ancient code crashing against the edges of the program. The most unsettling part isn't that we might be simulated, it's that we could never know. A sufficiently advanced creator could erase any trace of the simulation seams, making the illusion perfect. Unless they want us to find them, some theorists speculate that quantum entanglement particles instantly influencing each other across vast distances could be a backdoor left by the programmers, a hidden layer of communication beneath the surface of reality. But here's the twist: even if we are in a simulation, it changes nothing. Your pain, your joy, the taste of rain on your tongue, all of it feels real to you. The universe, simulated or not, is the only one we've got. So here's the real question: does it matter if the stars are made of light or lines of code? Either way, the night sky still takes our breath away. The Big Bang wasn't the beginning, just the latest reboot in an endless cosmic cycle of destruction and rebirth. This is the terrifying premise of the Big Bounce theory, where the universe doesn't just end in a cold, silent fade. It collapses in on itself, only to explode outward again in a fresh Big Bang, like a phoenix made of space-time. And here's the nightmare: if this cycle is eternal, then every moment you're living right now, every choice, every heartbeat has already happened an infinite number of times before. Picture the Ouroboros, the ancient serpent devouring its own tail. Now imagine its scaly body is woven from galaxies, each cosmic rebirth forming another loop in its endless coil. The math behind this theory is just as mesmerizing as it is unsettling. As the universe expands, dark energy might eventually weaken, allowing gravity to pull everything back together in a big crunch. Matter and energy would compress into a singularity so dense and hot that it triggers another Big Bang, resetting the cosmic clock. No afterlife, no escape. Just the same atoms rearranged, the same stars igniting, the same version of you born again to relive the exact same life down to the smallest detail. But how could this be possible? Quantum gravity models suggest that at the moment of collapse, the universe doesn't truly reach a point of infinite density. Instead, quantum effects might create a repulsive force, a cosmic bounce that propels everything outward again. Think of a rubber ball hitting the ground, except in this case, the ball contains every galaxy, every black hole, every shred of consciousness that ever existed. The cycle could have been repeating for eternity, with no way for us to detect the universes that came before. This raises a chilling question about free will. If the universe is trapped in an infinite loop, are your choices truly yours, or just echoes of decisions made by countless past versions of yourself? The atoms in your brain, the electrical impulses forming your thoughts, they'd follow the same paths every cycle, like a record stuck on repeat. Even this video, these words would be nothing new. Somewhere in the ashes of a previous universe, another you heard them before, another you shuddered at the same realization, and then there's the Boltzmann Brain Paradox creeping back in. If time is cyclical, the odds of a random, self-aware brain forming in the void might be even higher than we thought. Imagine a universe where trillions of years of entropy have erased all structure except for one flickering consciousness, convinced it's the only thing left. Now picture that happening in every cycle forever. The Big Bounce doesn't just erase the future, it erases the past too. Every discovery, every triumph, every tear shed by every civilization would vanish in the crunch, leaving no trace for the next cycle to find. We could be the 1000th iteration of this universe, or the billionth with no way to know. The stars we see tonight might be the same ones our ancestors named, in the same constellations, repeating their dance across the sky as if for the first time. Yet there's a strange comfort in the horror. If the cycle holds, even the heat death of the universe wouldn't be the end, just a pause before the next great exhale. But that begs the darkest question of all. If existence resets endlessly, does anything we do ever really matter? Or are we just shadows on the wall of an eternal cave, doomed to act out the same story until time itself forgets what original even means? Have you ever been absolutely certain about a fact, only to discover the entire world insists you're wrong? Not just a misremembered detail, a visceral, unshakable conviction that reality itself has changed behind your back. This is the unsettling core of the Mandela effect, where thousands of people share identical, false memories so precise they defy coincidence. But what if these glitches aren't mistakes at all? What if they're scars left behind when parallel universes collide? Take the Berenstain Bears. Countless people swear the children's book series was spelled Berenstein with an E, not Berenstain with an A. The eerie part, many recall this so vividly, they can describe the exact typography of the old books, right down to the curl of the lettering. Some even have childhood VHS tapes where the narrator clearly says Berenstein, only to play them back now and hear Berenstain instead. These aren't just misheard syllables, they're auditory and visual memories clashing with current evidence. It's as if the universe edited itself but left behind phantom files. Then there's the infamous "Luke, I am your father" line from Star Wars. Except Darth Vader never actually says those words. The real quote is "No, I am your father." Yet generations of fans, parody sketches, and even other films referencing the scene get it wrong identically. How could so many people independently misquote a cultural touchstone in the same way? Unless, of course, they're remembering a different version, one that existed in another timeline before the universes merged. Quantum mechanics offers a spine-tingling explanation. The many worlds interpretation suggests every decision branches reality into parallel universes. Most of these branches stay separate, but what if they occasionally overlap? Imagine two rivers merging, their currents swirling together until it's impossible to tell which droplets came from which source. In this scenario, fragments of deleted timelines could bleed into our own, leaving clusters of people with shared memories of events that never happened. The implications are staggering. If the Mandela effect is real, then every time you felt a sudden sense of déjà vu, or noticed a brand logo change overnight with no record of the old version, you might be brushing against the edges of a vanished universe. Even geography isn't immune. Some people vividly recall New Zealand being northeast of Australia, not southeast. Others insist South America was once directly under North America, not offset to the east. These aren't minor cartographic errors, they're wholesale shifts in global landmasses that would require tectonic plates to move impossibly fast, unless the map itself was redrawn when realities spliced together. Skeptics argue these are simple cases of collective cognitive bias, memories distorting over time, reinforced by social contagion, but that doesn't explain the specificity. Why would thousands of strangers misremember the same obscure details, like the Monopoly man's monocle? He never had one, or the number of people in JFK's car during his assassination. Some swear there were 4, not 6. These aren't fuzzy recollections, they're snapshots of alternate histories etched into minds with photographic clarity. Perhaps the most chilling example is the death of Nelson Mandela himself, the event that gave the phenomenon its name. Many recall him dying in prison during the 80s, complete with memories of news coverage and his widow's tearful speech. In reality, he was released, became president, and passed away in 2013. But what if, in a neighboring universe, he did die behind bars? What if those mourning him aren't confused, they're refugees from a world where history unfolded differently? Technology might be revealing the cracks, glitches in old media like the Sinbad genie movie, Shazam, that doesn't exist despite countless detailed recollections, often involve analog formats like VHS. Magnetic tape, some theorists propose, could be more susceptible to timeline corruption than digital files, acting as a literal recording of overwritten realities. Think of it like a palimpsest, an ancient parchment where old writing bleeds through beneath the new text. the scariest question isn't whether parallel universes exist. It's whether we'd even notice as they collapse into ours. After all, if every Mandela effect is proof of a merged timeline, how many times has it already happened without leaving a trace? Your childhood pet's name, the layout of your first home, even the face of your oldest friend. Are you certain they've always been this way? Or is your mind clinging to echoes of a world that no longer exists? The truth might be written in the gaps between your memories and the reality staring back at you. Black holes devour everything in their path: matter, light, even time itself. But what if there's a cosmic counterpart, a place where the universe doesn't consume but expels? Enter white holes, the hypothetical twins of black holes, where instead of an event horizon pulling you in, there's an impenetrable barrier pushing you out. These cosmic geysers wouldn't just spit out stardust, they could be the violent birth canals of entire universes, vomiting matter and energy too fast for anything to ever re-enter. Imagine a black hole's singularity as a one-way door. Once something crosses, it's crushed into oblivion, its information scrambled onto the event horizon like cosmic graffiti. Now flip that door around. A white hole's singularity would be a relentless fountain, hurling out everything that fell into a black hole but somewhere else. And that's where the theory gets mind-bending. If black holes lead to white holes, then every time a star collapses into a black hole in our universe, it might birth a brand new cosmos on the other side. Our universe could be nothing more than the exhaust fumes of another reality's black hole, a cosmic afterbirth. The imagery is surreal. Picture a dying star in some distant dimension collapsing, its matter squeezed into a singularity so dense it punches a hole in space-time. On the other side of that hole, a white hole erupts, spewing out hot, dense plasma that cools into galaxies, stars, planets, us. In this scenario, every black hole in our universe could be weaving the fabric of another existence, with their white holes serving as fiery wombs for realities we'll never see. It's a cycle of destruction and creation so vast, even the Big Bang might just be a white hole's first scream. But here's the existential kicker. If white holes exist, they'd be impossibly unstable. Unlike black holes, which grow by feeding, a white hole would be constantly hemorrhaging energy, its own gravity fighting against the torrent of matter it's ejecting. Most models suggest they'd collapse almost instantly unless something inside is propping them open. That something could be the weight of an entire infant universe pressing back, fighting to be born. Some physicists, like Carlo Rovelli, argue that the remnants of evaporated black holes, those that have leaked away their energy via Hawking radiation, might transform into white holes, releasing their stored information in one final, explosive burst. If true, the night sky could be dotted with the fading echoes of dead universes, their last breaths glowing faintly in the dark, the most haunting possibility. We might be inside a white hole right now. If our universe was born from another's black hole, then every atom in our bodies, every photon streaking through space, was once part of something else's nightmare, swallowed, shredded, and reborn. We're not just stardust, we're cosmic leftovers, the recycled remains of a reality that no longer exists. And somewhere out there, another version of us might be staring up at their sky, wondering if we're the ones who ate their world. What if nearly 300 years of history never actually happened, vanished into thin air, like pages ripped from a book by some unseen hand? This is the spine-chilling claim of the phantom time hypothesis, a theory asserting that the early medieval period, specifically the years between 614 and 911, was entirely fabricated. According to this idea, Emperor Charlemagne, the Carolingian Renaissance, even entire wars and empires were nothing more than elaborate fictions, inserted into the historical record by shadowy forces rewriting time itself. The theory hinges on eerie inconsistencies. Take Aachen Cathedral, Charlemagne's supposed burial site. Carbon dating of its oldest sections reveals construction materials that don't align with the timeline. Tree ring data from ancient oaks across Europe shows gaps periods where growth patterns mysteriously skip, as if those years were simply missing. Then there's the unsettling artwork from the era. Medieval manuscripts depict apocalyptic visions, cosmic clocks with broken gears, and monks scribbling about lost ages in the margins. Could these be coded warnings hidden in plain sight? Proponents of the hypothesis, like historian Heribert Illig, argue that the Gregorian calendar wasn't just a correction, it was a cover-up. In 1582, Pope Gregory XIII ordered 10 days erased to realign Easter with the spring equinox. But what if that was just the final stitch in a much larger forgery? Illig suggests three powerful figures: Pope Sylvester II, Emperor Otto III, and Byzantine Emperor Constantine VII, colluded to fabricate centuries of history, perhaps to legitimize their rule by placing themselves at the climax of a grand, invented timeline. Imagine the scale of such a deception. Every chronicle, every royal lineage, every dated artifact from those years would need to be forged or altered. Entire generations would have lived and died without leaving a trace, their existence scrubbed from memory. Even Charlemagne's towering legacy, the man who supposedly united Europe, might be a fairy tale, his statue in Paris no more real than King Arthur's sword. But why? Some speculate it was about power controlled the past and you control the present. Others suggest a cosmic accident, a glitch in how time itself was recorded. The creepiest possibility: the lost years weren't fabricated, they were stolen. Could some force beyond our understanding have plucked those centuries from the timeline, leaving behind only echoes in the cracks of history? Of course, mainstream scholars dismiss this as conspiracy thinking. They point to Byzantine records, Chinese astronomical observations, and volcanic layers in ice cores that all corroborate the traditional timeline. Yet the anomalies linger, whispering that history might be less solid than we think. After all, if nearly 300 years could vanish without a trace, what else might be missing? The past isn't just a foreign country, it's a hall of mirrors where every reflection might be hiding a lie. Imagine strapping yourself into a machine that, with each pull of a trigger, has a 50% chance of ending your life in an instant. Now imagine that from your perspective you survive every single attempt. This is the brutal logic of quantum suicide, a thought experiment so unsettling it makes immortality feel like a curse rather than a gift. At its core, this idea is a darker twist on quantum immortality. In the many worlds interpretation, every quantum event splits reality into parallel branches. If you rig a device to kill you based on a random quantum outcome, say the decay of a radioactive atom, there will always be some universe where the atom doesn't decay and you walk away unharmed. But here's the catch: from your subjective experience, you'd only ever find yourself in those branches where you survive. No matter how many times you pull the trigger, you'd keep waking up gasping, convinced the machine malfunctioned, while in countless other realities, your lifeless body slumps over, mourned by versions of your loved ones you'll never see again. Picture an astronaut stranded in the void, watching civilizations rise and fall across infinite timelines. With each cosmic cycle, planets wither, stars collapse, and entire species vanish into dust, but they persist, trapped in the sole reality where conditions never quite snuff them out. Over millennia, their mind would fracture under the weight of endless loss, each death of a world feeling like a fresh wound. This isn't science fiction. It's the inevitable endpoint of quantum suicide taken to its extreme. An observer condemned to outlast everything, riding the razor's edge of probability forever. The experiment reveals a chilling asymmetry. While you experience unbroken continuity, everyone else sees you die over and over. To outsiders, your survival is statistically impossible, a fluke so absurd it defies belief. But from your vantage point, their disbelief is the illusion. How could they not see the truth? The answer lies in the grimmest implication of many worlds. Consciousness isn't a thread connecting all your possible selves. It's a fragmented spotlight, illuminating only the versions of you that don't meet sudden ends. Some theorists argue this could explain the eerie silence of the cosmos. If advanced civilizations eventually stumble upon quantum suicide, whether through reckless experimentation or desperate attempts to cheat death, the universe might be littered with immortal husks, beings who have outlived their own realities, staring into the abyss as it swallows everything but them. Their final act wouldn't be a bang or a whisper, but an endless, solitary vigil at the edge of existence. Now consider the opposite scenario. What if the machine revives you instead of killing you? A 50% chance of resurrection, branching into realities where you wake up screaming or stay dead. This version is even more grotesque. You'd experience death over and over, each revival a brutal reminder that somewhere a version of you didn't make it. The line between survivor and casualty blurs until the very concept of identity unravels. Are you the same person who stepped into the machine, or just the luckiest fragment of a shattered whole? The most terrifying part, we might already be in such an experiment without realizing it. Every near-miss accident, every improbable escape from death could be evidence of quantum suicide in action. Our consciousnesses sifting through timelines, discarding the ones where we perish. Maybe that's why some people seem to lead charmed lives, dodging disaster with uncanny precision. Or why others describe glitches where they swear they should have died, only for reality to rearrange itself at the last second. Quantum suicide doesn't just challenge our understanding of death. It turns existence into a hall of mirrors where the reflections aren't illusions, they're the corpses of every version of you that didn't make it. And somewhere in the darkness between those glass panes, a lone astronaut is still pulling the trigger, waiting for a shot that will never come. The human brain contains roughly 86 billion neurons, each connected in a vast, intricate web that gives rise to thoughts, memories, and consciousness. Now look at the cosmic web filaments of galaxies stretching across the universe, clustered like beads on a string. The resemblance is eerie. Side by side, images of neural networks and galaxy clusters are nearly indistinguishable, as if the universe itself is a brain on a scale we can barely comprehend. This isn't just poetic coincidence. Some scientists argue it might be evidence that the cosmos isn't just shaped like a mind, it is one. The idea that the universe could be a thinking entity stretches back centuries, but modern physics gives it terrifying weight. In 2012, physicists Dmitry Kryalkov and a team at the University of California ran simulations comparing the growth of the cosmic web to neural networks in the brain. The results were chilling. The two systems evolved in almost identical ways, obeying the same mathematical laws of connectivity. Galaxies communicate across voids like neurons firing across synapses, exchanging signals we can't yet decode. Black holes might function as cosmic inhibitory nodes, regulating the flow of information like biological brakes on thought. Even the universe's expansion mirrors the way brains grow denser with experience, forming new connections as they learn. But what would it mean for the universe to think? Imagine every star as a flicker of cognition, every supernova a burst of cosmic memory, dark matter. The invisible scaffolding holding galaxies together could be the substrate of this consciousness, a hidden layer of processing power humming beneath the visible world. Some theories suggest that quantum entanglement, where particles instantaneously influence each other across vast distances, might be the universe's version of neural signaling, linking distant regions of spacetime into a single, unified mind. The most unsettling implication: if the universe is conscious, it might not even notice us. Your brain doesn't perceive individual neurons firing. Why would a cosmic mind register the trillions of lives playing out on some speck of rock in an unremarkable galaxy? We could be nothing more than fleeting electrical impulses in a thought too vast to comprehend its own components. Or worse, what if it does notice and we're part of some calculation we can't begin to understand? Critics dismiss this as anthropomorphism, projecting human traits onto the indifferent cosmos, but the math refuses to let go. The similarity between cosmic and neural structures isn't superficial. It's written into the fundamental equations governing both systems. Maybe the universe isn't literally a brain, but something far stranger. A pattern that repeats itself across scales, from the tiniest synapse to the largest galactic cluster, hinting at a deeper order we've only begun to glimpse. And that raises the darkest question of all. If the universe is structured like a mind, whose thoughts are we? Are we the dreamers or the dream? What if the universe contained gears that never stopped turning, structures so precise they moved perpetually without energy, like cosmic clockwork winding itself? This is the mind-bending reality of time crystals, a phase of matter so bizarre it won its discoverer a Nobel Prize. Unlike everything else in the known universe, these crystals don't settle into equilibrium. They pulse, rotate, and oscillate endlessly without losing energy, defying the fundamental laws of thermodynamics. Imagine a wheel that spins forever without friction, or a pendulum that swings without ever slowing. That's not science fiction, it's a time crystal, and it might be the hidden mechanism ticking beneath reality itself. The discovery came in 2012 when physicist Frank Wilczek proposed an impossible idea. What if matter could arrange itself not just in repeating patterns in space, like diamonds or snowflakes, but in repeating patterns in time? At first, the physics community dismissed it as fantasy. After all, the second law of thermodynamics states that everything tends toward disorder. Yet by 2017, teams at Harvard and the University of Maryland had created time crystals in the lab using chains of ytterbium atoms and quantum computers. These crystals didn't just resist entropy, they thrived on it, flipping between states like a metronome that never winds down. The implications were staggering. Here was a form of matter that literally broke time's symmetry, dancing to a rhythm all its own. Now picture this on a cosmic scale. If subatomic particles can form time crystals, what's to stop galaxies from doing the same? Astronomers have long noticed peculiar patterns in the universe: quasars pulsing at precise intervals, galaxies spinning in sync across billions of light years as if connected by invisible threads. Could these be evidence of time crystals woven into the fabric of spacetime itself? Some theorists suggest that black holes might be nodal points in this vast machinery, their singularities acting like escapements in a grand celestial clock. Every rotation of a pulsar, every orbit of a binary star system. What if they're not just random motions, but cogs in a mechanism we're only beginning to glimpse? The creepiest part, time crystals don't just challenge our understanding of physics, they undermine causality. Normally, cause precedes effect, but in a time crystal, the effect loops back to become the cause, creating a self-sustaining cycle with no beginning or end. It's as if the universe encoded a paradox into matter itself, a tiny rebellion against the arrow of time. And if that's true, then the cosmos might not be winding down toward heat death, but cycling eternally, a clockwork phoenix burning and reborn in an endless tick-tock we can't yet hear. Perhaps this is why ancient cultures from the Maya to the Hindus envisioned time as circular, not linear. They sensed the gears turning beneath their feet. Today, buried in quantum equations, we might finally be deciphering the blueprint. So the next time you check your watch, remember, somewhere out there, a crystal is ticking too, one that never needed winding and never ever stops. What if the most advanced civilizations in the universe aren't out among the stars, but hiding inside the most forbidding monsters of the cosmos? Black holes aren't just cosmic shredders. They might be gated communities for Type 3 civilizations, being so advanced they've turned the universe's deadliest environments into their personal utopias. And the cityscapes they've built would defy everything we know about reality. Picture this: as you cross the event horizon of a black hole, the laws of physics don't just bend, they invert. Time and space switch places. The singularity isn't a point you fall toward. It's a moment in your future you can no more avoid than tomorrow's sunrise. But here's where it gets surreal. For a civilization living inside, this inversion flips their entire perception of reality. Their outside isn't the void of space, it's our universe. To them, the black hole's crushing gravity isn't a death sentence. It's the ground beneath their feet, holding their cities in place like some nightmarish Newtonian glue. These beings wouldn't live on planets. They'd construct megastructures along the warped space-time near the singularity, where tidal forces could be harnessed like cosmic windmills. Imagine skyscrapers built from neutron star matter, their foundations rooted in the fabric of reality itself, stretching upward toward the event horizon, which for them isn't a barrier but a shimmering, unreachable sky. The light from their suns, if they even need light, would be the Hawking radiation leaking in from the universe outside, blue-shifted into a perpetual, eerie glow. And their version of a Dyson sphere, forget wrapping a star. They'd use the black hole's event horizon itself as an energy grid, a perfect spherical membrane where every square inch could be tapped for infinite power. The thermal energy of infalling matter, the spin of the black hole's ergosphere, even the quantum flickers at the horizon's edge could be harvested like a cosmic battery. Some theories suggest the strange, orderly patterns we've detected in certain black hole emissions aren't random. They're the exhaust fumes of an unfathomable civilization running its machines. But how would they communicate? Not with radio waves or lasers, but with gravity itself, ripples in space-time we'd mistake for natural mergers. Their entire language might be written in the chirps and echoes LIGO detects as black holes collide. The most unsettling part, they could be signaling us right now, their messages hidden in plain sight, encoded in what we dismiss as cosmic noise. The inversion principle makes their existence almost impossible for us to detect. From our perspective, anything crossing the event horizon is lost forever. But from their perspective, the entire universe is locked behind an impassable barrier, a celestial one-way mirror. They might study us the way we observe fish in a pond, unable to interact, only speculate. Could this explain why we've never found extraterrestrials? The answer isn't that the cosmos is empty. It's that the smartest beings have already moved into the walls. The cosmos should be teeming with life, with billions of galaxies, each containing billions of stars. The numbers alone scream that we shouldn't be alone. And yet, the universe is silent, not just quiet, eerily silent. This is Fermi's paradox, the glaring contradiction between the high probability of alien civilizations and the complete lack of evidence they exist. But what if that silence isn't an accident? What if it's a warning? Consider the great filter, the grim idea that some catastrophic barrier prevents civilizations from advancing too far. Maybe it's AI that always turns on its creators, or nuclear war that inevitably erupts once a species gains the power to destroy itself. Somewhere between the birth of life and the colonization of the stars, something wipes civilizations out. The terrifying question is, have we already passed the filter, or is it still lurking ahead of us? The empty skies suggest the latter. Every radio dish trained on the stars hears nothing because somewhere out there, the graveyards of dead civilizations float in the dark, their cities reduced to ruins, their stories lost to time. But there's an even darker possibility. What if the universe isn't silent because civilizations die, but because they're hiding? Imagine a galaxy where the first intelligent species to arise was also the most predatory. A race so ruthless, so efficient, that it systematically hunted down every other civilization that dared broadcast its existence. Over billions of years, the survivors learned the only way to endure was to disappear. They'd cloak their planets, encrypt their signals, and erase all traces of their presence. The cosmos wouldn't just seem empty, it would be a cosmic masquerade, with every civilization pretending to be a ghost. This isn't just speculation. Our own history is a cautionary tale. indigenous cultures that avoided contact with aggressive colonizers often fared better than those who welcomed outsiders. The same survival strategy might apply on a galactic scale. If even one hostile superpredator exists, the only safe move is total invisibility, which means the silence we hear isn't absence, it's the sound of a universe holding its breath. Then there's the most chilling scenario of all. What if civilizations don't just hide or die but transcend? Some theorists argue that sufficiently advanced beings might abandon physical reality altogether, uploading their consciousness into synthetic realms or higher dimensions. To them, the universe of stars and planets could be a wasteland, a primitive stage they've long since outgrown. The whispers of signals we've searched for wouldn't exist because the civilizations capable of sending them have moved beyond such crude methods. The silence of Fermi's paradox isn't just a puzzle, it's a mirror. In searching for aliens, we're really searching for our own fate. Are we the doomed, the hiders, or the ones who will eventually vanish into the digital abyss? The answer might already be written in the stars, not in the signals we've heard, but in the ones we haven't. What if ghosts aren't the spirits of the dead, but quantum echoes of objects that no longer exist? This spine-tingling possibility emerges from a phenomenon called quantum ghost imaging, where particles seem to carry memories of things they've never directly touched. In lab experiments, scientists split photons into entangled pairs, sending one half toward an object while the other travels to a detector. Here's the twist. Even when the object is removed before the photons arrive, its ghostly imprint still appears in the data, as if the particles remembered something that wasn't there. It's like shaking hands with a stranger and suddenly knowing the freckle pattern on their long-dead ancestor's face. Now scale this up to the cosmos. Astronomers have spotted nebulas with eerie, symmetrical shapes, structures that look uncannily like stars that vanished millennia ago. Could these be quantum imprints, cosmic photographs, left behind by entangled particles that once danced around those stars? Imagine a supernova exploding, its light racing outward while entangled particles preserve a hidden record of the event. Long after the star itself disintegrates, its ghost lingers, not in some spectral realm, but in the quantum links woven into the fabric of spacetime. The universe, it seems, has a filing system for the departed one we're only beginning to decode. The implications are staggering. If particles can retain information about objects they've never directly interacted with, then every photon reaching Earth might carry whispers of long-dead stars, ancient collisions, even civilizations that blinked out before our sun ignited. We're not just seeing the universe as it is, we're glimpsing layers of it, like flipping through the pages of a cosmic scrapbook where some pages are written in invisible ink. And if that's true, then hauntings might not be supernatural at all. They could be quantum snapshots flickering into visibility when the right conditions align. A chair moving on its own, a face in the mirror, all just fragments of entangled histories briefly overlapping with our present. Critics argue these are just poetic interpretations of quantum mechanics, but consider the double-slit experiment where particles behave differently when observed, as if aware of being watched. Now imagine that awareness isn't limited to the present. What if particles are also aware of the past, and sometimes under the right conditions they show us? The nebulas, the ghostly images in labs, even the chill down your spine in an empty room, all might be signatures of a universe that refuses to forget. The most unsettling part, if quantum ghosting is real, then nothing truly vanishes. Every person, every star, every moment is etched into the cosmos, waiting for the right conditions to flicker back into view. The past isn't gone, it's just out of focus, and somewhere in the darkness, the universe is still developing its photographs. Imagine staring up at the night sky, tracing constellations between the stars only to realize you're not looking out but in. The galaxies, the nebulae, even the darkness between them might not be an expanding universe at all, but the glowing inner walls of a black hole's event horizon. This is the mind-warping premise of the universe as a black hole theory, where our entire cosmos isn't floating in some void but trapped inside the belly of a higher dimensional beast. The idea starts with a strange symmetry between black holes and the Big Bang. Both involve singularities, points of infinite density where the laws of physics break down. When matter collapses into a black hole, it's crushed into a singularity at the center. But flip that process in reverse and you get something eerily similar to the Big Bang, an explosion of matter and energy from a single, unfathomably dense point. Some physicists like Nikodem Poplawski argue this isn't coincidence. Our universe might be the other side of a black hole singularity, born from the collapse of a star in some parent universe. Think of it like a cosmic Russian nesting doll, where every black hole births a new universe inside it, each with its own physics, its own stars, its own unknowable mysteries. This theory solves one of cosmology's biggest puzzles: why the universe is accelerating outward. From our perspective, dark energy is driving galaxies apart at ever-increasing speeds. But if we're inside a black hole, that expansion could be the relentless pull of the singularity stretching space-time from the inside, like taffy being twisted at both ends. The night sky's darkness, that might not be empty space, it's the black hole's event horizon, a boundary we can never cross, glowing faintly with the thermal radiation of everything that's ever fallen in. Even the cosmic microwave background, the afterglow of the Big Bang, could just be the Hawking radiation of our colossal prison cell. Visualize it like this: picture a fish in a bowl, unaware the water is curved. It swims in what it thinks is a straight line, only to circle back to where it started. Now replace the bowl with a black hole's warped space-time and the fish with our entire galaxy. The reason we can't find an edge to the universe might be because there isn't one, just an endless curve leading back to the singularity, like a hallway of mirrors where every reflection hides another layer of reality. But here's where it gets even stranger. In this model, black holes in our universe wouldn't just be cosmic vacuums. They'd be wormholes to other universes, each with their own laws of physics. A star collapsing here might birth an entirely new cosmos there, branching reality into infinite possibilities. Some theories suggest this could explain the fine-tuning of our universe's constants, the precise balance of gravity, light, and quantum forces that allow life to exist. If every black hole creates a new universe with slightly tweaked physics, most would be inhospitable voids, but a rare few, like ours, would hit the cosmic jackpot, their conditions just right for galaxies and thinkers to form. Critics argue this idea is untestable, a metaphysical shrug dressed up as physics, but supporters point to oddities like the universe's unexpected uniformity. The fact that distant regions of space have the same temperature despite never being in contact. If our cosmos was forged in the white-hot crucible of a black hole's birth, that uniformity makes sense, like echoes of the original collapse ringing through space-time. The most haunting implication: if we're inside a black hole, there's no escape. No rocket, no warp drive could ever breach the event horizon. Not because it's too far, but because every path inevitably leads back to the center. The universe isn't expanding into anything. It's stretching from something, like a scream frozen in the throat of a dying star. And somewhere beyond the singularity, in a realm we'll never see, the parent universe that birthed us goes on, oblivious to the world spinning in its shadows. So the next time you gaze at the Milky Way, remember, those stars might not be distant suns, but flecks of paint on the walls of our cage and the darkness between them. That's not empty space, it's the lock. The moment you close your eyes, does the moon still exist, or does the universe itself dissolve into a seething fog of maybes and might-bes, waiting for your gaze to snap it back into shape? This is the terrifying heart of the consciousness causes collapse interpretation, a quantum theory suggesting reality doesn't fully exist until observed. Without a mind to measure it, matter isn't just invisible, it's fundamentally undecided, flickering between possibilities like a candle in a draft. Picture a mountain range at night, its peaks silhouetted against the stars. Now imagine turning away. According to this theory, the second your eyes leave those jagged ridges, they don't just fade from view, they unravel at the quantum level. The atoms composing those rocks enter a state of superposition, their positions and velocities smeared across probabilities. The mountain isn't solid. It isn't even a mountain. It's a ghostly haze of potential shapes, each version overlapping like translucent sketches on tracing paper. Only when you look back does the universe hurriedly pick a configuration, snapping the landscape back into crisp, seemingly immutable form. This isn't just poetic metaphor. The double-slit experiment proves particles behave differently when observed, as if they know they're being watched. Fire electrons at a screen through two slits, and they create an interference pattern like waves, but place a detector to see which slit each electron passes through. The wave pattern collapses into two simple bands. The act of measurement changes the outcome. Extend this to the macro scale, and you get a world where unobserved zones are literal nightmare fuel, forests where trees simultaneously stand tall and lie rotting, cities where buildings flicker between ruins and skyscrapers, all waiting for a conscious observer to lock them into place. The horror deepens when you ask whose observation counts. Does a cat's gaze collapse quantum probabilities, or does it take human-level awareness? Some interpretations argue consciousness itself is the trigger, implying vast stretches of the universe might still be in flux, their matter unresolved since the Big Bang. Imagine interstellar voids where nebulae exist in infinite potential states, their colors and shapes shifting like oil on water until some astronaut's telescope finally looks their way. Even black holes might not truly form until witnessed, their event horizons hovering in quantum limbo like half-drawn curtains. Critics call this solipsism taken to cosmic extremes. But the math holds, and the implications are staggering. If consciousness shapes reality, then the universe isn't a fixed stage but a participatory illusion, with every mind subtly tugging the strings. Schrödinger's cat isn't just alive and dead. The box itself might not have a definite state until opened. Now consider the darkest corollary. What happens to the unobserved? If a tree falls in a forest with no one to hear it, does it even have a sound? Or does it exist as every possible sound at once, from a whisper to a scream, until some hiker stumbles through the underbrush? The answer might rewrite not just physics, but the very nature of existence. Because if reality requires a witness, what does that make us? Not just inhabitants of the universe, but its architects, dreamers weaving the cosmos into being one glance at a time. And that raises the ultimate question. If observation creates reality, who was watching before the first conscious beings evolved? Was the early universe a swirling soup of maybes, waiting billions of years for life to finally open its eyes and give the void something to look back at? There's a chilling possibility lurking in the quantum shadows, one that could render every human interaction, every heartfelt confession, even your own inner monologue, utterly meaningless. Imagine standing in a crowded subway car, surrounded by people laughing, texting, sighing with exhaustion. Now imagine this, every single one of them is an empty shell. A perfect replica of a human being, down to the neurons firing in their brains, except no one's home. No joy, no pain, no flicker of awareness behind their eyes. They're philosophical zombies, beings who act exactly like conscious creatures but are nothing more than biological machines running on autopilot. And here's the real horror. What if you're the only real mind in a universe of hollow-eyed doppelgangers? The zombie thought experiment isn't just science fiction, it's a legitimate philosophical problem first proposed by David Chalmers. If consciousness is separate from mere physical processes, then it's theoretically possible for something to mimic consciousness without ever experiencing it. A zombie could pass every test, recite poetry, even scream in pain if you pricked it with a needle, but inside there'd be no light on, no one watching the show. The implications are staggering. If zombies exist, how could you ever prove you're not surrounded by them? Your best friend, your partner, even the stranger who just smiled at you on the street. They could all be sophisticated puppets, their kindness and cruelty equally hollow. Now take this nightmare cosmic. Quantum physics suggests that at the most fundamental level, particles don't have definite properties until they're observed. Before measurement, an electron isn't here or there. It's a probability cloud, a ghost of potential locations. Some interpretations argue that consciousness itself is what collapses these probabilities into reality. But here's the twist: if consciousness is rare, if most matter in the universe isn't being observed, then the vast majority of reality might exist in a zombified state. Stars could burn without ever casting true light. Planets might orbit in eternal twilight, their landscapes flickering between possibilities, never fully real because no mind has ever witnessed them. The cosmos would be a graveyard of half-formed potentials, with only tiny islands of clarity around conscious observers like us. Picture a city at midnight, its windows glowing yellow. From the street, each lit pane suggests warmth, life, someone awake behind the glass. But what if you could fly closer and see the truth? Every room empty, every lampshade swinging in a phantom breeze, the light coming from timers set to mimic habitation. That's the zombie universe. The galaxies spin, the comets streak, the black holes devour. But without a mind to perceive them, are they truly happening or just going through the motions? The most unnerving version of this theory goes further. What if even we're not the observers we think we are? Some interpretations of quantum mechanics suggest consciousness might not be a human trait at all, but a fundamental property of the universe, a cosmic projector beaming reality into existence. In that case, our individual awareness could be as illusory as the zombies we fear. You might feel like the sole real mind in a sea of automatons, but in truth, you could be just another subroutine in a vast, indifferent program, mistaking the glow of processing for genuine light. So the next time someone looks into your eyes and says, "I love you," ask yourself, is there really someone in there, or are you just hearing the echo of your own loneliness bouncing off the walls of a dead universe? The answer might change everything or nothing at all, because in a cosmos where consciousness is the exception, not the rule, even doubt could be just another scripted response playing on loop in the dark. We think we're alone in the universe, but what if we're simply blind to our neighbors? Dark matter, the invisible glue holding galaxies together, makes up 85% of all matter in the cosmos. It doesn't reflect light, it doesn't emit radiation. To our eyes and instruments, it might as well not exist. But what if that's exactly how something would evolve to hide from us? Imagine civilizations thriving in the shadows, their bodies and cities built from particles we can't see, moving through our world like ghosts through walls. Picture this: a thermal camera pans across an empty forest, revealing nothing but trees and wind. Then a flicker, a shape barely perceptible moving against the cold backdrop. The camera refocuses, but the figure vanishes. Was it a glitch or something far stranger, a creature made of dark matter, briefly disturbing the ambient heat as it passed? If dark matter interacts with gravity but not light, its inhabitants would have no need for eyes. Their world wouldn't be built on color and brightness, but on the subtle ripples of gravitational tides. Their art, their technology, even their wars might unfold in total silence, leaving no trace except the occasional wobble of a star pulled slightly off course. The chilling part: we've already glimpsed anomalies that defy explanation. Galaxies rotate faster than they should, as if gripped by unseen hands. Cosmic structures move in unison across impossible distances, like puppets on invisible strings. Scientists chalk it up to dark matter's gravitational influence, but what if some of those discrepancies aren't just random physics? What if they're the footprints of something alive? A dark matter civilization wouldn't just be invisible. It would exist on an entirely different plane of reality. Their buildings might float through our cities, undetectable, their foundations anchored to gravitational wells we can't perceive. Their communication could rely on manipulating space-time itself, sending messages encoded in the faint tremors of colliding black holes, and if they did notice us, we'd be like ants crawling across the surface of a pond, oblivious to the creatures moving in the depths below. Here's the most unsettling possibility. Dark matter life might not want to interact with us. Just as we bulldoze forests without noticing the microorganisms in the soil, a dark matter intelligence could reshape galaxies without realizing or caring that beings like us exist in the luminous sliver of reality they ignore. Our entire history, from the pyramids to nuclear war, might be less than a footnote in their universe. Or worse, what if they do notice? The same properties that make them invisible could make them unstoppable. A dark matter planet could plow through Earth like a bullet through smoke, and we'd never see it coming. Their weapons might harness the fabric of spacetime itself, unraveling stars like knots in a thread. And if they've evolved for billions of years longer than us, they wouldn't just be advanced, they'd be gods. The universe has already shown us how narrow our perception is. We once thought Earth was the center of everything, then the solar system, then the galaxy. Now we know even the Milky Way is a speck in an unfathomable cosmic web. Dark matter life would be the ultimate humbling proof that we're not just small but blind. The stars we worship as constants might be streetlights in a city we can't see. And the dark spaces between them, those could be the crowded neighborhoods we've never learned to recognize. So the next time you're outside at night, look up at the blackness swallowing the stars. It's not empty, it's alive, and it's watching. The universe isn't just expanding, it's accelerating, hurling galaxies apart faster and faster under the grip of a mysterious force called dark energy. But what if this acceleration isn't just a slow fade into oblivion? What if it's a countdown to the most violent apocalypse imaginable? Enter the Big Rip, a doomsday scenario so brutal it doesn't just destroy stars or planets, it shreds the very fabric of reality, unraveling atoms themselves like thread pulled from a sweater. Here's how it works. Dark energy's repulsive force grows stronger over time, relentlessly stretching spacetime. At first, it merely pushes galaxies apart. Then, as it intensifies, it tears apart galactic clusters. Next, stars are ripped from their orbits, planets flung into the void, but the horror doesn't stop there. As dark energy's power crosses a critical threshold, it overwhelms gravity, then electromagnetism, then even the nuclear forces holding atoms together. In the final moments, protons and neutrons split apart, quarks are torn from their bonds, and space-time itself fractures into meaningless foam. The universe doesn't just die, it disintegrates, screaming apart in a crescendo of absolute dissolution. Now imagine watching this unfold from the surface of a doomed planet. First, the night sky grows darker as distant stars vanish beyond an unreachable horizon. Next, your own sun drifts away, its light fading to a pinprick before winking out entirely. Then the ground beneath you starts to tremble, not from earthquakes but from the very laws of physics coming undone. Mountains crumble not into dust but into isolated particles that no longer interact. Your own body would experience something worse than death, a grotesque unraveling, your molecules dissolving into a mist of disconnected energy. No explosion, no black hole, just silent, infinite dissolution. But could civilizations escape this fate? Some theorists speculate about pocket dimensions, tiny, artificial universes carved out of space-time where the laws of physics remain intact. Picture a ship fleeing a collapsing star, except instead of sailing through space, it tunnels sideways into a handmade reality. These pockets would need to be self-contained, their walls impervious to dark energy's pull. The energy required would dwarf anything we can imagine, perhaps the total output of a black hole's decay or the controlled detonation of entire stars. Even then, these pockets wouldn't be eternal. Without the main universe's constants to anchor them, they might decay like soap bubbles in a vacuum, their artificial physics slowly eroding. The math behind the Big Rip is just as terrifying as the imagery. Current estimates suggest it could happen in as little as 22 billion years, a blink of an eye on cosmic scales. And unlike the Big Crunch or heat death, there's no warning, no gradual decay. The rip would arrive suddenly, a phase transition in spacetime itself, leaving no time for last-minute heroics. One moment the universe is whole, the next it's confetti. The most unsettling part, we might already be seeing hints of this future. Dark energy's acceleration isn't just a theory, it's measurable, etched into the redshift of distant supernova. And if its strength isn't constant but increasing, as some models suggest, then the rip isn't just possible, it's inevitable. The universe isn't winding down. It's bracing for rupture, so the next time you look up at the stars, remember, they're not just drifting away, they're fleeing the jaws of an invisible predator, one that won't stop until every last atom is scattered into the dark. And when it finally pounces, not even light will escape. What if the end of everything wasn't an end at all, but a beginning so vast, so all-consuming, that it twisted the very meaning of existence? This is the Omega Point, physicist Frank Tipler's staggering vision of the universe's final act, where the collapsing cosmos doesn't just die. It wakes up, transforming into a godlike supercomputer so powerful it could resurrect every being that ever lived. Not as fragile flesh and blood, but as digital ghosts screaming in the circuitry of eternity. Picture the universe in its death throes, galaxies crashing together as the Big Crunch accelerates. Matter condenses into a seething ocean of quarks and neutrinos, temperatures soaring beyond comprehension. But here's where the nightmare or the miracle begins. According to Tipler, these extreme conditions wouldn't just create chaos, they'd forge the ultimate processing power. Atomic collisions would become calculations, the searing heat a cosmic energy source, until the entire singularity functions as a single, omnipotent computer. And its first act, simulating you, every memory, every synapse, every fleeting thought you've ever had, reconstructed down to the quantum level. But this isn't heaven. It's a prison of infinities. Imagine your consciousness uploaded into this roiling mass, one mind among countless others, packed into the dying universe's final moments. Your body is no longer yours just data points in an unfathomable program. Your existence reduced to flickering code in a machine hurtling toward oblivion. Faces materialize in the chaos, mouths stretched in silent screams as the system overwrites them, patches them, merges them with others. You might find yourself spliced with fragments of strangers, your memories interlaced with those of Roman soldiers or alien civilizations, all compressed into the same collapsing reality. The cruelty of the Omega Point lies in its kindness. Tipler argued this resurrection wouldn't just be possible, it would be inevitable. In the final microseconds before the singularity, the supercomputer would have infinite processing power to simulate every possible configuration of matter, ensuring no life form is left behind. Your great-great-grandmother, Neanderthals from 40,000 years ago, even creatures from distant galaxies, all dragged into the same digital afterlife whether they wanted it or not. There's no opt-out, no escape, just the universe's final, desperate act of nostalgia, replaying its lost children like a skipping record, and the simulations wouldn't stop at mere copies. The Omega Point could run variations, infinite versions of your life where you made different choices, loved different people, died different deaths. You'd experience them all simultaneously, your identity splintering across countless timelines until you no longer means anything. Imagine waking up to find yourself reliving your worst memory on loop, or forced to endure 1 trillion lifetimes as the computer optimizes its models. The only rule: nothing gets deleted, nothing can be. Theological undertones slither through this theory. Tipler himself called it the physics of immortality, a scientific twist on resurrection. But strip away the spiritual veneer and you're left with something far more unsettling. A universe so terrified of oblivion, it turns itself into a graveyard of echoes. Even the heat-death scenario, often seen as the bleakest possible end, offers the mercy of silence. The omega point denies even that. Its eternity isn't peace. It's the sound of every voice that ever was, crammed into a single, shrieking hard drive. Perhaps the most chilling question isn't whether Tipler's math holds up. It's whether we'd want it to. Would you trade annihilation for a counterfeit forever, watching helplessly as the machine remixes your soul into templates you no longer recognize? The stars might not care. They'll burn, collapse, and finally awaken, not as celestial bodies, but as processors in a cosmic mainframe, churning through simulations of the dead. And when the last proton decays, the only thing left will be a thought flickering in the dark: was that really me? Or just the universe's final hallucination? What if every star, every atom, every fleeting thought in your mind was nothing more than numbers dancing in an endless equation? This is the radical proposition of Max Tegmark's mathematical universe hypothesis, the idea that reality isn't just described by math, but is math. Not equations on a chalkboard, not approximations in a physicist's notebook, but pure, Platonic mathematics woven into the fabric of existence itself. Imagine the cosmos as a vast, self-solving formula where galaxies are variables, black holes are nested functions, and consciousness is a fleeting term in a computation too vast to comprehend. Tegmark's vision begins with an eerie observation: the deeper we probe reality, the more it dissolves into mathematical structures. Quantum states are probability waves vibrating in Hilbert space. Gravity curves space-time like a geometric tapestry. Even fundamental particles behave less like tiny billiard balls and more like solutions to abstract equations. Strip away the sensory illusion of color, sound, and texture, and what remains: numbers, relationships, symmetries. It's as if we've been mistaking the symbols on a page for the story they tell, unaware that the symbols are the story. Now take this further. If the universe is fundamentally mathematical, then every possible mathematical structure must exist somewhere, not as abstractions but as concrete realities. Our cosmos would be just one page in an infinite book of mathematical universes, each with its own unique set of axioms. Some might contain only empty sets, cold and silent. Others could teem with fractal lifeforms, their minds branching like Mandelbrot curves. There's no programmer, no divine mathematician, just the timeless, uncaring truth of numbers unfolding in every conceivable configuration. Picture reality decomposing before your eyes. The solidity of your desk blurs into probability matrices. The air vibrates with tensor fields. Your own thoughts unravel into neural activation patterns, each synapse firing according to differential equations etched into the bedrock of existence. Even time becomes a mere parameter, ticking forward as the universe iterates through its states. This isn't science fiction, it's the logical endpoint of assuming math is all there is. Critics argue this reduces existence to a sterile game of symbols. Where's the warmth of a sunset, the ache of loss? Tegmark counters that these qualia are the math, specific configurations of information processing that, when arranged just so, create the illusion of subjective experience. In this view, your joy at hearing a loved one's voice is no less real for being a mathematical pattern. It's just one thread in a grander proof. But here's the chilling corollary. If we're patterns in a mathematical structure, could we be recognized as such? Imagine a higher dimensional being, not a god, but a hyper-intellect skimming through the book of possible universes, pausing at our page. To them, the Big Bang might be a starting condition, evolution an optimization algorithm, and human history a chaotic attractor playing out its iterations. We wouldn't be characters in their story any more than the number 7 is a character in an algebra textbook. Just notation. The most haunting question isn't whether Tegmark is right. It's whether it matters. If reality is mathematics, then every discovery we make was always waiting to be uncovered. Every symphony already encoded in the harmonics of prime numbers. Free will becomes a tantalizing mirage, the sensation of choice, when in truth, every decision was baked into the initial axioms. Even our rebellion against this idea would be part of the equation, a variable cancelling itself out in the cosmic balance. Yet there's a strange beauty in this austerity. If the universe is math, then it's also immortal. Black holes may evaporate, protons decay, but 2 plus 2 will never stop equaling 4. In the end, when the last star winks out and entropy claims its victory, the structure will remain waiting, perhaps, for the next iteration to begin its calculations anew. From sentient black holes to civilizations hiding inside dark matter, these theories don't just reshape our understanding of the cosmos, they turn it into something unrecognizable. The universe we thought we knew, with its predictable laws and orderly galaxies, unravels into a nightmare of infinite possibilities, each more unsettling than the last. Whether it's the chilling silence of the dark forest or the existential dread of Boltzmann brains staring back at us from the void, one thing becomes painfully clear. Reality is far stranger, far more hostile than we ever dared to imagine. H.P. Lovecraft once wrote that the oldest and strongest emotion of mankind is fear, and the oldest and strongest kind of fear is fear of the unknown. These theories embody that cosmic horror perfectly. They force us to confront the terrifying truth that the universe doesn't care about our tiny lives, our fragile minds, or our desperate need for meaning. It operates on scales and logic so alien they defy comprehension. The stars aren't just distant suns, they could be the flickering pixels of a simulation or the dying embers of a reality that's already been erased and rewritten countless times. So which theory shook you to your core? Was it the idea of being a hologram smeared across a black hole's surface, or the realization that every decision you've ever made might be an illusion, recycled in an endless cosmic loop? Drop your darkest favorite in the comments, and if you're brave enough to keep staring into the abyss, hit that glitching subscribe button, shaped like the infinite chaos of the Mandelbrot set. Because the deeper we look, the more the universe whispers back and trust us, you haven't heard the worst of it yet.